please speak up, interrupt me at any moment. I can adjust this according to your interests. The presentation, so I have two parts here. The first part is a presentation that is supposed to give you some kind of overview over what this tool is and why I built it. And the second part is a short demo. I have two demos prepared. We can choose one of them after or even do both, depends on how much time we have. Okay, so the tool is called Sieves, plug and play document AI with zero-shot models. A little bit, whoop. Oh, now here we go. So I've prepared a Slido for questions. You can use that if you want to, or you can just, like, as I said, raise your hand or just interrupt me at any point, whatever you prefer. If you want to use the Slido, it's tinyurl.com/OSA-Sieves. Okay, a little bit about me. I am working as a machine learning engineer in natural language processing. I'm currently working for Climatic, which is a climate tech company in Berlin. Before that, I've been in the space, the machine learning space, for the last 12-ish years. And the last 5 or so, I've been focusing very heavily on natural language processing. So in my trajectory, the last 4 companies I was at, the first one is Enlight AI, which is a Viennese and Austrian machine learning consulting company. Then Explosion, which maintains and makes Spacey. You might have heard of them if you're in the NLP space, especially. Then Mantis, which is a natural language processing focused consultancy, and now Climatic. So in 3 of those companies, I've been involved in plenty of consulting projects, which are usually proof of concept projects, greenfield projects. Essentially, someone talks to you and says, hey, my business has this problem, right? I want to know if I can solve this using machine learning. So you do some research, you get a toy data, you get an exemplary data set, you try to find a solution that works, and you build a prototype, you evaluate it, and you present it. So a lot of greenfield work, basically starting from scratch every time. Oh yeah, and I'm also forgot to mention, I'm also volunteering at Mnemonic, which is a human rights organization that focuses on data archiving and integrity. So I'm also doing this kind of work there. All right, so plenty of greenfield projects I've worked on in the space of natural language processing, specifically machine learning in general, in the last years. And there's some problems that you run into when you have a cold start to a project in machine learning, especially in natural language processing. So pre-LLM, in those ancient times when you couldn't use like ChatGPT or other models to just do zero-shotting, you had to collect and label training data, you had to engineer features, and you had to train your model before you had actually something that you could test, right? Now with LLMs, that is not always necessary anymore. So you can zero or few shot a lot of problems, especially if they're vanilla, meaning that they're not super complicated or they're not using any particular very esoteric kind of data that they hadn't been trained on. So the turnaround from idea to first prototype for such greenfield projects in NLP has been reduced greatly. That's amazing. That's very useful. And when I talk about NLP projects, there's a kind of distinction I would like to introduce here. This is not complete, this is not exhaustive, so don't hold my feet to the fire over that. But this is a kind of a distinction that has been very useful for me in my career as NLP and machine learning engineer. Generally, you can distinguish NLP projects into 3 different categories like these days. At least like 90% of the projects I've worked on could be distinguished into one of these 3. The first one is like a chatbot or co-pilots in that sense, meaning you have this flow from user to LLM to user to LLM. So that's one use case. The second use case is retrieval, or RAG as the contemporary version of that, which is the user wants to find something. So you get a query, you have to find the matching results. Maybe you want to summarize the results, and that's what you return. That's the second use case. And the third use case, which is the one that I happen to work the most on, and I suspect might also be one of the most frequent of those 3, is document processing. So essentially, you work on this, or work within this paradigm that You have a bunch of different documents, right? And in each document, there's like some pieces of information that you want to extract or that you want to summarize, or you want to do something with them. But it's unstructured information, right? Which is why you need NLP in the first place. So given that I was running into this cold start document processing kind of situation many times, I was wondering how could I minimize the time from the idea or specification of such a use case to a working proof of concept. So the focus here was, how can I make this easy for myself? How can I make this fast for myself? And so over time, I accumulated this wish list. Like, what would I like to have for a situation like that? The first thing is that I would like to have no need for training data, because there's like, collecting training data, then training a model is always a bit of a hassle. Secondly, I don't want to reinvent the wheel for well-defined tasks. Like the majority of use cases uses the same set of like, I don't know, maybe less than 10 tasks that you can like, combine in various ways to get what you want. I would like structured output. This is an issue that when you work with LLMs, you will know. They are trained to emit natural text, fluent text. They're also trained to emit structured output meanwhile, but it doesn't always work. So you need a way to ensure that you're getting the output in the format that you're using. Because especially when you're working with this document processing use case, your consumer is not a human being. Usually it's another computer system somewhere downstream, right? It's another program, it's another application, it's another component. So you need the output validated in exactly the structure and exactly the format that you specified. Then observability. Like if I build my prototype and it goes wrong, I would like to know what is happening. Furthermore, it should be model agnostic. I don't want to be tied into like to Anthropic or OpenAI or any other model vendor. It doesn't matter whether they're open or not. I would like to have the flexibility to just switch my model at the whim. Another important thing, low effort data handling. So when you work with document processing, your documents can be in any kind of shape and form, right? They can be PDFs, they can be already texts, they can be maybe like spreadsheets even. They can be Word documents. So I would like this solution that helps me with my proof of concept project, with my greenfield projects, to be able to parse all sorts of file types. And output, similarly, the output format should be something that's like standardized and something that is easy to also train my models on, so that I can build my proof of concept, right? I rely on zero-shot models, I rely on LLMs. This proof of concept produces output, and then I could actually maybe like train my own local models. So I don't need to use these big energy and money intense LLMs all the time. And finally, this solution should be able to handle arbitrary document lengths. This is also an issue with LLMs, that they have a certain context length. And these days, the context length is sometimes already like quite big. The closed vendor models that have the longest context lengths these days, I think the context length is somewhere around like 1 million tokens or something like that. So it's really long, and usually you won't run into problems with that. But especially if you want to use your own local models, for example, these sometimes still have context windows of like 8K, 16K tokens. So if you have longer text, like for example, you couldn't just throw a book in there, like this would be too long for the context window. So you would have to find another way to deal with that. Right, as an aside, and I'm just gonna put this up for discussion now, like to your decision. I can talk a bit more about what structure generation is, if that is something that's interesting to you. So like Mike, Andrew, Patty, what do you think? Is it something you would like to hear more about, or should I just skip this and move forward? Okay, I'll just do a quick overview then. All right, so what is structure generation? That is generation or generating output that aligns with a certain schema or a certain grammar. So it can be a specific JSON schema, or like a pydantic type if you work with Python, or can be a regex or something like that. And why do we want that? As mentioned, because often the downstream consumer is not a human being. The downstream consumer is sometimes like another system, right? Another piece of software that expects that it gets maybe one integer and one string, and they're named like that, and they're constrained like that. And if not, then it fails. So we need to guarantee that. And we can get there by doing fine tuning and graceful parsing, or by doing something that's called constrained token decoding. There are dedicated libraries to do that, such as outlines, for example. So these are all Python libraries. Like I'm all talking Python. And there are also general purpose LLM frameworks that offer these features, like DSPY or LangChain. And sometimes it's also an LLM vendor feature. So sometimes vendors also offer that as a feature directly when you use, for example, the OpenAI API, or since recently also the Anthropic API, and other vendors too, I'm sure. They have a structured output feature where you can that you can use directly without having to use any of these other libraries. All right. So this is an example for constrained token decoding. This is maybe it looks a bit overwhelming, but actually like it's quite easy. Like at every step, if you imagine LLM, it generates a new token, right? And usually the LLM just chooses the token with the highest probability. And that's how it generates the text that you see. However, with constrained token decoding, we want to limit the option so that the LLM doesn't necessarily choose the token with the highest probability, but it chooses the token with the highest probability that fits the schema, the grammar that we gave it, right? So for example, in this case, we constrain the output to like a certain sequence of words, like you want a date of birth has to appear right in the text. So in this, for example, this first column, born, the word born would have the highest probability, but it doesn't fit our grammar because we said the sentence needs to start with date. So it's not chosen, but instead the word date is chosen, which is like the third most likely object, the third most likely token. So that's the idea essentially, that you look into the token probabilities and then choose the highest, the most likely token that fits the schema. That's how constrained decoding is done usually. So the good news for all of these individual items on my wish list is that all of this is at least approximately solved. So the no need for training data, I mentioned before, you can use LLMs or other zero-shot models. That's all fine. For structured output, you can use constrained decoding or other methods to guarantee that. You don't need to reinvent the wheel if you just have some sort of task library. It's more of a software design thing, really, than it is technology. For observability, same thing. It's also a software architecture decision, right? Like you can have things be very observable if you have modularity. If you consider basically your software as one big black box and you throw an input and you get an output, then it's hard to say what happens on the inside. And that's basically what an LLM does. So if you take your entire problem, throw it into an LLM, and you get an output, and maybe that output is good and maybe that output is bad. But if it's bad, you can't really do much in order to understand why it's bad. You can't really look into an LLM and understand what's happening. What you can do, however, is you can have this modular. You can decompose a problem into like subproblem 1, then subproblem 2, then subproblem 3. And then you can solve your problem in this modular manner. And then you can look into the outputs of your individual modules, right? And say, okay, like the first part of the subproblem, that is all fine. Second part as well. But in the third part, something breaks down. So we need to look into this. Yes. And this leads me to this. And this is not done by me. This is from an article by Matt Honeyball, one of the founders of Explosion. And he has this great blog that I would strongly recommend. It's from 2023, but it still holds up very well. And it addresses this whole conversation around modularity in LLMs. That is like sometimes very tempting to just like take all of that entire problem, throw it into an LLM, and then take the output, right? And that works in a pinch, and that's fine. Often for simple problems, that's fine. But once your problems start to get more complex, you want some modularity in there. And that's not really just related to LLMs. That's more of a software architecture thing. But it's especially important with LLMs because, as I said, LLMs really are a black box. Even if you run your own local LLMs, like it's absolutely not trivial, if possible at all, to understand why they do what they do. Right. So moving forward with my wish list, like this model agnostic behavior I would like to have is also possible with API design. It's also just a software architecture question, low effort data handling. Meanwhile, there are these a lot of these tools that would call like X to Markdown parsers. Like if you know Docling, maybe you've heard of that, or Markdown. They have been immensely popular over the last, I don't know, 1-2 years. They have like, I don't know, Docling has probably like 60K stars on GitHub now or something like that. So what they do is they became so popular because of LLMs, because they resolve exactly this issue. They take all kinds of file formats, be it a spreadsheet, a Microsoft Doc, a PDF, a website, whatever. They parse it and they output Markdown. And that Markdown, since it's more or less like natural text, and that's also what LLMs have been trained on, they are very readable and very well understandable to LLMs. And for outputs, there's also like an established thing there. For example, Hugging Face datasets is more or less a standard format for training models. So this is also mostly solved. And finally, the arbitrary document lengths. This can also be solved by just saying, I mean, there are lots of ways to treat chunking. This is especially relevant in the context of RAGs, of retrieval augmented care, but a very naive solution that often works is like if you have a book, for example, a book is too long for the context window, you split it in several parts, and then you solve each part, and then you merge these solved parts together, essentially. So that also is more or less solved. The bad news, however, at least at the time when I started working on Sieves, that no single tool like this exists yet. So like all of these individual things have been solved, but I would still need for every time to like cobble together my own solution. But of course, where this is going. Sieves is supposed to solve all of this, to work, to function as the single tool that helps them with like this greenfield projects, and with doing document AI, document processing in a simpler and more straightforward way, and to minimize the time that we spend on working on creating a prototype. So Sieves is a toolkit that's supposed to speed up the prototyping of document AI use cases. So why prototyping? You can use it in production as well. There's no reason against that. But depending on your use case, you might want to have like more control over specific aspects of your solution. So primarily, it's intended to get a first working prototype off the ground very quick. But there's also no reason why you can't use it in production if it fits your use case. The design focus with Sieves, it is document centric, as I mentioned, document processing. We don't care in this case about like RAG or retrieval or like this chatbot pattern. We care about documents. All outputs are structured outputs. Like there's no natural text in the outputs. Like it's all well-defined types. You have to specify what you want to get out of it, and that is what you get out of it. Modular execution via pipeline. So you don't have one big program, but you have several steps that all solve like parts of your problem. And then you can access those results and you have all of your results. And finally, a small API surface. There are plenty of NLP tools out there, right? This space has exploded since LLMs really started to make a splash in the last years. A lot of these tools also try to solve everything. Like the best example for that is LangChain. I don't know if you've worked with LangChain. I've tried it in the past. I really dislike it. I don't want to throw shade on LangChain now. This is not the point. But it is this very big, very complex like thing of like 100,000 abstractions, 100,000 classes, 100,000 things. You can do all of them, but it's like a bit difficult and cognitively challenging, like to find the right way, right? So here the idea was like this should do like a certain subset, like a specific use case, and it should do it well, and you don't need to learn a lot of abstractions in order to make it It's opinionated. So like I want to use existing tools like docling, for example, which I mentioned, or like Hugging Face datasets to all like address these individual challenges. I don't want to reinvent the wheel in Sieves. Like I want to use what's already available. It should be model agnostic and tool agnostic. So as I mentioned before, like for example, there's outlines for structure generation, but there are also other options like DSPY and LangChain, for example. It should be zero and few at first. So nothing that you do in Sieves relies on trained models. It all works with zero-shot models. You don't have to train anything. And other thing that's not super important or as important is batching. So you can do things like somewhat efficiently. So if you're familiar with this Anthropic terminology, like this is not an AI agent, it's an AI workflow. It's a series of well-defined steps, one after each other, each of which uses AI to solve something. What is it not? As mentioned, it's not a retrieval system. It's not a chatbot. It's also not an agent. It can be used with some agent configurations, but I think that's like a bit of an advanced topic we're going to skip now. But you can define your models. What it does expect is it's like a model, right? It expects some sort of model instance, and that model instance can be configured to use tools, but it is something that is done outside of Sieves. For example, DSPY is a library that allows you to set up your model, and you can just use the model. You can use the model in combination with tools, or you can use a configuration of the model essentially that acts as an agent. But it is not central to Sieves. Sieves in itself is not an agent framework or an agent library, although it can work with agents. It's also not a replacement for the structure generation libraries, and it's also not a fully fledged workflow orchestration system. Like it has a very, very simple pipeline extraction. You do one thing after the other. Yeah, and enough talk about that. So thanks for bearing with me for all of this like long-winded introduction. This is some code that shows generally how to work with Sieves. So there are three main abstractions here that are relevant if you want to work with it. The first one is the document. The document is just a single central unit of information. The second one is a task. A task is this like this submodule, right? Like if you decompose your problems, your use case, you will come up with like certain things you need to do. Maybe you need to classify something, or maybe you need to extract information from a document. Maybe you want to summarize the document. So these are these reusable patterns that like every problem can be decomposed into. And finally, there is the pipeline. And the pipeline is just like a series of chain tasks. You do one task after the other. So in this example, what we do first is we define our model. And in this case, we use an outlines model that uses a transformers that basically wraps a transformers, a pretty small one. Then we define a document. In this case, it's a single document. This is like a special relativity, applies to all physical phenomena, et cetera, et cetera, et cetera. But this is our one document, right? And then our dummy document. And then we create a pipeline. And in this case, we say our pipeline consists of two steps. First is classification. So is this about science or is it about politics? And we do supply the task with the model so that the task knows, hey, oh, okay, this is the model I can use to solve this problem for this document. And then a question answering task. So like we ask it, who introduced special relativity, right? Which is in the text, so it should be answerable. And then finally, we just run this pipeline. That's the last line you see that's not commented. So for doc in pipe docs. And then we print the results for each document. We only have one document, so we only see one output block here. And in this case, we get, for the classification task, we get a result, a tuple that says, okay, so this is science has a probability of confidence of 1 and politics of 0.3. Obviously, this document has nothing to do with politics, but in the defense of this model, it's a very tiny model, and it's also an older model. But anyway, it got it right. Like this document is about science and not about politics. And for question answering, we get back the answer Einstein, which is also good enough for like a tiny locally running model. So this is the very basic way to use Sieves. You define your documents, you define the model you want to use. And again, the model can be anything. The model can be GPT 5.2. The model can be like a tiny model that runs locally. It can be a Hugging Face model. It can be LangChain. It can be DSPY. It can be outlines. It can be a lot of things. And third, you define your pipeline, which is basically you define your task, you define what you want to do. And then at the end, the last step is you run the pipeline. And that's it. And that's like the majority of the API surface that you need to know. There are more details to that, of course, which we will touch on in the demo, but this is the basic way to use it. Yeah, I already talked about that, but like these are the abstractions, and the main abstractions that are relevant for us are the document, the pipeline, and the task. Everything else, I think I'm going to skip these other things for now because they're all irrelevant really if you want to extend Sieves or if you work as a maintainer, but they're not relevant if you're a user.
I have a short question.
Yes, go ahead, Mike.
Can you go back 2 slides where you have this, another one? Where you have this, the model has to be the same. So of course you can specify the model for the classification and the question answering. Is it, I think it's recommended to have the same or could be different models. Would it make sense to have different models for different tasks?
Yes, absolutely. For example, classification, you probably want to use the most efficient model, right? So one use case could be that one thing, one of your problems, one of your tasks is like very complex and you need a big LLM for that. And maybe the other one is very simple, like it's a classification between, I don't know, like the science and politics, right? There are a lot of local, small, very efficient models that you could use for that, but that only can do classification and they can't do question answering, for example. So you might want to say, okay, I'm using a local, fast, efficient, small classification model for the classification task, but for the question answering task, I will use a big, very capable, flexible LLM.
Okay.
Does it answer your question?
Yeah, because but the interface to these models can be pretty different if they use very different technologies in the background. But your abstraction around provides a kind of standardized API, so that's you don't
exactly
you don't say, you just say model and you don't give anything else. You just say model and the model is doing it somehow.
Yes.
And you the only thing classification you feed the labels, and the only thing for the question you feed the question answer you feed the question. That's it. Okay.
Exactly. Yes. So like I have this kind of like wrapping mechanism on the inside that looks at the model, says, okay, this is this kind of model, this is that kind of model. That's how I interact with the model.
Okay.
But as a user, you don't need to know about that. There are certain libraries that are supported. So as I mentioned, you can supply a LangChain model, you can supply an outlines model, a DSPY model, a Gliner model, and like these, and we can talk about it more in detail later. But essentially, these kind of models are on a spectrum from more efficient, but also more constrained in what it can do. Like for example, a Hugging Face, Zero-Shot classification pipelines. They are also supported, but you can only use them for a classification task, right? Because they're just like classification models. They can't do anything else. And the other end of the spectrum, you have LLMs that can do everything, but of course they're also like more costly.
Yeah.
So you can pick your model from the spectrum depending on what kind of task you solve. You can also use the same model for every task if the model can do that.
And if some model takes some special parameters that only make sense for this model, could you say, okay, now I want to have this, I want to give something extra, or is it just everything is just like this, so everything will be generated? Or can you say, okay, I want to fine tune this model because I know this model and this needs some parameters which just doesn't exist, or parameter doesn't exist for the other model?
Yes, you can also pass these arguments. So
you have extra arguments that might only make sense for some types of models. Or is this
so what you can do is, yeah, exactly. So what you can do, these tasks, they have like as an extra argument to have something that's called like init quarks essentially. Or inference quarks. So if you know that your model at inference time, at runtime, needs a specific argument that you want to set, maybe you want to, I don't know, max tokens, for example, right? You want to limit the number of tokens that it produces. You can put that in the inference quarks dictionary in that argument, and then it's going to be injected into the model at runtime.
So you have extra arguments, so to speak, that are special for a model, and you can still specify them.
Yes, so like the user has the flexibility.
Style,
Yes, because as you said, like these models all have very different interfaces, right? So I couldn't like standardize that in any way, but I can
that's
give
why I was
the user
surprised
flexibility.
that it works for all kind of model. Would be very strange because you need to sometimes customize a little bit for this model, for this model.
Exactly. Yeah. I mean, by default, like it works without setting any like inference or init quirks, right? But
Yeah.
sometimes you want to use them, and in that case, you can.
Okay. Good. Great. Thanks.
Okay. So if this kind of like architecture, it's kind of design sounds similar to you, then you might know it from Spacey. And I am certainly biased. Like I worked with for Explosion for a while. But I also think that one of the things that Spacey got right was the overall pipeline design, the overall architecture. Like Spacey is not really in use that much anymore because it kind of got like, it didn't get the switch to LMs and this new style NLP at the right time. But the architecture and the pipeline design, generally, I think, was still smartly done. So, and there you have this pipeline. You also have this central doc paradigm that all the information is stored in a doc, and every component receives a number of docs and outputs a number of docs. And all of the information is just accumulated within these docs. So yeah, that's what it did. So I thought the Spacey API design is very smart. It does make a lot of sense. So I just very liberally borrowed from it. And I'm not ashamed about it. I think it makes a lot of sense. So we talked about the task library before briefly. So as I said, the task library is there so you don't need to reinvent the wheel. So complex problems can often be broken down into simpler tasks. Your use case might have like 100 requirements, but often you can say, okay, in order to fulfill these requirements, we first have to do this, then we have to do that, then we have to do that, right? It's like how you're solving problems for yourself. Like if you have to resolve something, you don't just jump into and you try to do everything at the same time. You kind of break it down into tasks for you, and okay, this task needs to be done before that task, and so you kind of like create this map, this pipeline of tasks for yourself. And often these simple tasks are very frequent patterns. Like for example, classification, right? Classification is like the number one thing in NLP probably. There are so many use cases that are either solved or partially solved by classification. And there are also others that are often occur repeatedly. So the tasks that Sieves currently supports are classification, named entity recognition, sentiment analysis, summarization, information extraction, where information extraction is basically saying, hey, I want to find this kind of information in text, and then it's going to be extracted from the text for you in a structured way. Personally identifiable information anonymization, translation, and multi-question answering. So these are the tasks that are currently supported. They will be extended, but they cover like some ground within the space. If what you want to do is not one of those things, then you would need to implement your own task with Sieves, which you can do, or you just like write me an issue on the repository and I'll try to get to it. Happy to do that. So it's relatively easy to extend, but of course, like I'm the maintainer, I'm biased. It might not be that easy for you. I hope that it will be. Other quality of life features in Sieves that I think are important, like there's persistence. You can serialize and deserialize your pipeline and your documents. You can do distillation, although this is currently implemented only for the classification task. But the idea is that, as I mentioned before, you might want to train your own local specialized model, right? Maybe you want to prototype with an LLM because you have zero data, but you can use basically the LM data, or you can use the LM as a teacher, right? You can use the data that you got from the LM, and based on that data, you use that as the training set, train your own model. So this is distillation. And that is a feature, but as I said before, it's currently only implemented for the classification task. There's caching. So if you by accident like throw the same document or like the same text into the pipeline is going to identify that and is only going to execute the pipeline on every unique document and is then duplicating the results for the duplicated documents. As a short guideline on when to use Sieves, like what's the niche? Like when should you use it? When should you use something else? So I'm going to focus mostly on the left column, on the like this is when you should use it. So we talked about this already. Use case, use for document processing, yes, correct. Doesn't really make a lot of sense for chatbot, definitely not. If modularization is important for you, if your problem is so simple that you might not even need modularization, if you think you can just like throw the LM and get a straightforward answer right back at you, then you probably don't need Sieves. Structured output. Like if you don't care about structured output, you don't care about Sieves. Utility handling. As I mentioned, Sieves is opinionated, and the idea is to get you from your starting point to a working proof of concept at least, and maybe beyond that, as fast as possible. So that includes that a lot of these utilities like dataset generation or like ingesting different file types, right? This is all built in. This is all done for you. If you already have a stack or like a solution that works with structured generation, like if you're already like knee deep in, for example, I don't know, LangGraph, or sorry, not LangGraph. If you're already knee deep in DSPY or outlines, or you already have like, you know, like 3K lines of code that is written with this framework, it doesn't make sense to switch, most likely, right? But if you're working on a greenfield project, if you're starting from scratch, or like you don't have a lot of good quality code already that does that for you, it does make sense. Related to that, project stage, greenfield, excellent. Bluefield, if you already have something, depends. Brownfield, basically, if you're already in production and you have already chosen like your framework and everything, probably not the best choice to use Sieves then. Your priority is shipping speed. If your priority is like optimization, like throughput optimization, for example, you know, like you probably want more control that you can do something with VLLM or other tools, right? And yeah, project complexity, that again depends. Like I think Sieves is probably best in like medium complexity things. If your problem is so simple, you can just like throw it in an M, get an answer back, and you're happy. Then you don't need to start doing that with Sieves. Same thing is, a project is super complex and you need to be in control of everything. That also relates to the project stage, right? And what your priority is. It's also like questionable whether it's the right choice, but for everything in between, I think Sieves is decent. All right. So if you have added anything to the question board here, I guess not. I mean, this is a very small. Yeah. In this case, we can take a short break here and see if there are any open questions. Anything you want to ask, anything you want to discuss. Okay, then I would proceed. And we have two demos that I prepared for today that show a little bit more how to use this. One is, so one of these, the classic NLP 101 example, right? That the first thing you do usually is like, how do you build a spam filter to classify mails as spam or not spam? And I wrote a Sieves version, a zero-shot version of that. So there's one thing. The other thing is like analyzing an article on chat control. So these are the two options that we have. So I'll try to finish this within 1 hour. So this presentation we can extend if you want to, but I don't want to assume more of your time. So my questions here is, who would prefer the spam filter example and who would prefer the chat control example? So let's say a spam filter first. So who prefers that? Okay, one vote for Mike. Andrew, so. Okay, chat control. None. Okay, all right, cool. Then I'll just go with the spam filter example. If we still have time, we can have a look at the other demo as well. Just give me a second. I just need to start up the notebook server. All right, you're still seeing my screen, right? Okay. All right. So as I mentioned, so the classic NLP, first thing you do, first thing you get taught if you start into this is like, oh, we're building a spam filter. And we're building a spam filter by having a look at the email text, and then we're doing some back of words thing, right, where we see how many words, like how's the distribution of words in spam emails, and how is the distribution of words in non-spam emails, and then we train a model, and then we have a spam filter. Okay, so this is my take on this. This is like how would we do that with zero-shot models, right? So to start with, I say we build a data set. So what we do is we import our document class from Sieves, and these are some very short spam and non-spam emails that had generated by ChatGPT. So instructed to give me like 3 emails that look like spam and 3 emails that don't look like spam. And these are like every second one is not spam. So this, for example, is spam, this is spam, and this is spam, and the other emails are not spam. So this is the data we're working with. Of course, in reality, we would not work with like super short text, but this is just for better visibility and to keep things simple. Okay, so that's the first thing, right? We built our data set. The second thing then is we define our model. In this case, I've decided to go with an LLM just to show you how this could be done. So I'm using Open Router, and I'm using DSPY as the library I'm working with. So if you're not familiar, DSPY is an LLM programming framework that has a very, very interesting approach to how to work with LLMs. And what I'm doing here specifically is I say, okay, this is basically this is the model I'm using, right? I'm using Gemini 2.5 Flash. Not the newest model, but it's like quite okay. It's relatively cheap. It's relatively fast. I'm using Open Router just as like where this model comes from. This is not really important. And then I'm just defining a model in this DSPY native way. So like there's no Sieves here. This is just really say, okay, I basically create my DSPY model. And you can do it in the same way for the other supported alternatives, which is like Hugging Face Zero-Shot pipelines, Gliner, Outlines, and LangChain. So you can define a model with either of those alternatives or DSPY, and just plug it into any of these Sieves tasks. So we have defined our DSPY model, which uses Gemini 2.5 Flash Lite. And we're building, as the next thing, we're building our pipeline. And looking at this example, one thing that you want to do for your emails maybe, right, is like first you want to classify them whether they're spam or not spam. So that's the first step. And then the second step is maybe, okay, I don't want to read all of that stuff. I will also want to have a summarization of the emails. So what we do here is we define our two tasks. What we import is the tasks package, right, that contains all of the tasks. And then something called, this is actually not even necessary. We'll get rid of that, and then we don't need to talk about it. So we just import the tasks package, and then we say, okay, we build our classifier. So we do, hey, tasks classification. We say our labels are spam and not spam. We say multi-label is false. So multi-label is like, the normal multi-label classification. If that's true, then the classifier tries to predict the likelihood of each of the labels. And if it's false, then it just tells you, hey, this is probably this label or that label. Then it's just only predicting for one label. We set that to false because in this case, we're only interested in that. And then we, again, supply the model. So this is the model we defined up there, right? This is the DSPY model. Okay. And then we do the same thing for the summarization task. So we say task summarization. In this case, we say we want a very short summary. We just say this is like 10 words. And again, we supply the model. Mike, as mentioned before, right? For example, you could use a different model for the classification. If you didn't want to send this classification task to an LM, if you would want to solve it locally with a faster specialized model, you could do that as well. In this case, for simplicity's sake, we say, okay, we use the same model for both tasks. And then we create our pipeline, which is basically just like adding these two together. Like we say, okay, the pipeline is first a classifier and then a summarizer. And that's that. Like the whole config here is actually already done. So let me actually execute that so we can do this step by step. Okay. Right. So we have done this. And what we do now is that we execute the pipeline because we are already done with the configuration. So the execution is happening if you just take the pipeline object and you just send your list of documents through that. The list of documents, these docs, if you remember, these are the ones we defined up here. So these are 6 documents, 3 of which are spam, 3 of which are not spam. And we just say, okay, for document in the pipeline execution of the documents, what we get back here, we say, okay, we print the text, and then for each document, we print the results, right? In this case, we first print the results for the classification task, and then we print the results for the summarization task. So if we execute that, and it's already done, that was very fast because it's just 6 documents. So we print the document text, right? So this is, dear user, we detected unusual activity on your account to avoid immediate suspension, blah, blah, blah. So this is a spam email, and it's correctly classified as spam with like an 89% confidence. Having said that, these confidence values are like a bit, like basically I'm just asking the LM to provide a confidence value, which is not a real confidence value, but it's like, it gives you some information. The next one, hi team, I wanted to share a quick update on the project. The initial phase is complete and we are on track to begin next steps, blah, blah. This is normal work email. It's also verified as not spam. So that's also right. Oh yeah, and I forgot to mention, right? Then we have the 10-word summary here, right? So for example, for the mail above is like verify account details via link, blah, 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 to prevent suspension. This is kind of accurate. Initial project phase complete. Next steps start early next week. Also kind of is the gist of this mail up there, right? So and this goes on and on for the rest of the documents. I don't think we need to look at every single one of them. So this seems to work fine enough, right? So this looks reasonable. We could do this, and we could have a working pipeline for spam classification and summarization in those like 5 minutes it takes to write this config up there. This model, the tasks, and the pipeline. But then we might say, okay, but actually we don't care about summarizing the spam emails, right? We just want to get rid of them. We just want to ignore them. And of course, in this example, it doesn't matter because it's just free emails. But when you're working with real data, imagine this is actually, you have a data set of, I don't know, like a few thousand emails, right? And you want to classify all of them, and then you want to summarize all of them. If this number is high enough, then actually this presents somewhat of a pain to you because you want to minimize the number of steps, the number of or like the amount of data you send to the LLM, for example, right? Because you want to save costs, you want to save time, you don't want to compute stuff that's not necessary to compute. So you actually want to say, okay, I want to classify into spam and not spam. And if it's not spam, then I want them summarized. If it is spam, I don't care. I don't want to do the summarization. Like I don't want to waste my time and my computing power and my money on this. So for this, there is something, and this is now just like a little bit more of an advanced feature. It's like still pretty easy, I like to think, but there is something called conditionals in Sieves, where you can say a task should only be executed in those documents that fulfill a certain condition. So we do the same thing again, like in this case, instead of just like a summarizer, we say we're now doing a conditional summarizer. So conditional summarizer, all tasks in Sieves have this condition argument. The condition argument, that's basically, it has to be a function that evaluates to true or false for any given document. And if it's true for this document, then this task is executed for this document. So in this case, for example, we said we only want to summarize if the email is not spam. So in this case, we can say, okay, this is just a function, like this is a lambda, so it's just a headless function. And we say, hey, for any given document, if the results of the document is not spam, so like this is 0 because going back at this is the result, right? This is the result for classification. So it's a tuple where you have at the 0 index, you have the label, whether it's spam or not spam. And at the 1 index, you have the confidence for this. In this case, we're only interested in the label. So we say, hey, is this label, the predicted label for this document, is this spam or is it not spam? And in the case it's not spam, you should execute this task. Otherwise, this document is skipped. So now we have defined our conditional summarizers. So we redefine our pipeline, say, okay, this is the improved pipeline. Again, we do the classifier. That's the same task as before. We haven't changed that. And it's a conditional summarizer. And we do the same thing as before. We say we just like run through this improved pipeline. We put in the same documents. And then again, same thing as before. We print the results for classification. And we print the results for summarization. And I can run this again. It was already, again, very quick, probably because it was cached from the previous run. But let's have a look, right? So again, we said we first print the text. So this is the text of the email. We know the first email is a spam email. And also just the classification, right? It gives us the same result as before. It makes sense. But then in this case, for the summarization, we see this is none. If you remember from before, I'm going to show it again. We actually had the summary, right? Like we had the summary for the first mail, which was a spam email. Now, this summary is none. And this is just like the placeholder value that is inserted for this step, right? So that we have a result, but this is none, meaning that this task was not executed for this document. And now we go to the next mail, right? The next mail was not a spam mail. If you remember, it's like this, hi team, I want to share a quick update on the project, etc., etc., etc. It is not spam. And we have a summary. So you can configure this pipeline to be more targeted, or like if you have a situation where you have like a million documents and you want to do like a first kind of filtering step essentially, right? Because that's what it is usually in practice. You want to filter down your entire data set to like a smaller data set of things that you want to do a more sophisticated analysis on. In this case, you can use these conditionals. You can filter down and basically ignore the rest of the documents. Okay, so this was the first demo. It is 6 p.m. If there's interest, I can go for the other demo. Otherwise, we would end it here. What do you guys think? Just let me know.
Does the other demo that API looks really clean and easy to use? I really appreciate your API. It looks really nice. Does the other demo demonstrate? Is it the same API in a different context, or is it doing sort of using other tools, other features that your software provides?
It is using other features, yes.
It's very nice. So I think I'm going to try using Sieves. If I can get to that point in my to-do list at some point. I'm very interested in it. I don't, if there's time, it's kind of interesting to see the other features.
I mean, I can also just like show the other demo. Like I can just focus on the features that we haven't seen here. And I mean, anyone who is not interested can just drop out, I guess. We can do it like this. And that's if there's no reason not to do it like this.
I'm here as long as everyone wants to hear from us. So no limit to the time for me. And
okay.
Yes, for the rest, if you need to drop off, that's fine. We are recording the session, so you can catch up on what you missed when we post the recording on YouTube.
Okay. All right, then let's do that. Right, so the other demo, as mentioned, is about chat controls. Like chat control, I don't know if you're familiar with it. Like if you're in Europe, probably are. This basically surveillance mechanism that was supposed to be introduced and then was voted against. It was rejected, but now it's popping up again, right? I guess kind of like it always comes back. So in this case, like the use case is basically, hey, like I would just have some like in-depth questions about this topic, right? So what can I do? Like in this case, we say we introduce our data set again as before, but in this case we don't define the text. We just give define a URI. So this is the link to the website. And this is an article by the Electronic Frontier Foundation on chat control that discusses like the current situation. You can see it's like from December 2025, so it's like reasonably up to date. And so we do the same thing here. Like we don't really need to look at this. This is all the same thing. We define TSPY like a model again. This is all good. This is all good. But in this case, we are doing something else. Like so, this is the other feature that I mentioned before. One thing here is there is this special task which is called ingestion. So the ingestion task takes a document that is not pure text, but it can be a website or it can be a Microsoft Word document, can be whatever, right? So behind the scenes, it's using Dockling. And Dockling is able to take all of these documents kind of and translate them into text, right? So we define this document up there. This is just a link, right? But actually want to work with the text. So we say, okay, just this link, and then run the ingestion task. The ingestion task takes this link and parses the website into Markdown, and then puts this Markdown code into the text value of the documents. So this is what we do, and then we say, okay, we use some other tasks, right? Like so, we use the question answering task, for example, right? And in this case, we can pose some questions, and then we do a sentiment analysis task to kind of understand the author's stance on this. But like these things are just like, they don't really show different features of Sieves. It's just like, well, it's different tasks, but it's the same kind of interface. But the ingestion one is the one that's most interesting, I think, in this demo, because it showcases that you don't have to fill in the text to your document. You can just like add a link. So this link could also be a file link. It could be a link to PDF, for example. It could be a link to a doc file, to like a Microsoft Word file. Basically everything that the docling library can handle, this can handle. And the ingestion task will translate, or will extract all of the text from this document, and we'll put it in the text value of our doc instances. And that all happens in the first step. And then the rest of the tasks just operate on this text, on this extracted text value. Right, so that's that. And we define the pipeline, we define a few tasks. Something that may be interesting here is what we're doing is we're also doing this information extraction, right? And information extraction means like we have a specific kind of entity, a specific kind of information in mind that we want to extract from the text. And in order to do that, we're using Pydantic. So Pydantic allows you to define these classes that vary with like a high degree of precision, represent what you're looking for in our case. So in our case, for example, we say, okay, this is a newspaper article, right? And we're interested in the topic, so maybe you're looking for related literature on this. Maybe you want to read more. So what we can say is, okay, within this newspaper article, within this Electronic Frontier Foundation website article, we want to find related literature because we're interested in learning more about this. So we are saying that here we define this class. So this is basically our entity. This is what we're looking for. We say we call it related literature. And we describe this is another article on the topic of chat control. And we say, okay, this is the topic and this is the link. And then we just like add it to the pipe with the information extraction task, where we say, okay, entity type, the one we're looking for, that's this one. And then we run the pipeline. Actually, like I hope I started this correctly now, and I can just like rerun all of this to get the output. But essentially, that's that. Like, there's not much new features here that we didn't discuss in the previous demo, but it's mostly the ingestion task and the related literature. It just takes a few seconds to like import all of these libraries, but yeah, and there it is, and we've run it, right? So like we've run it, and now we're looking at the results. So the first one is like summarization. We've seen it already. So basically, this is like running the pipeline, right? And then we just like pick the results object for the first document because we only have one document here. This is the result for summarization. We've seen it already. This is like for question answering. Like for question answering, we've posted like I think 2 different questions. So here we say, okay, we have a result for question answering, and here we have 2 results for question answering actually, because we post 2 questions. So this is the response to the first question about the risks of chat control. This is this question. And then the second question was about like, why is this coming up again already after it has been rejected? It had been rejected in the past. So this is an answer to the second question. Then this is like the result for sentiment analysis. Basically, we say, we ask for the sentiment of the author on like digital rights organization, which is a pretty high one. So like they are talked about highly in the article, which is no surprise, right? It's the EFF. So of course they talk highly about those. And they talk very badly about chat control, right? Like they have a very low opinion of chat control, which also makes sense. And for the information extraction task, this looks like this. So if you remember, we had this Pydantic class defined, which had as 2 attributes, a topic and a link. And we just described in free text what those are, right? And the LM is picking up on the description we gave this class, on the class name and on the class attributes, and then looking for those in the article text. And then we basically just like, okay, for all of the things you found for the information extraction task that we gave you, we just like print exactly that out. We print the article topic and we print the article link. And so we see here, these are the results, right? So these are like all the articles that the model found in on the website article that we fed to it. And they're like all about chat control, right? Or most of them seem to be about chat control. Like once again, chat control, AI and secure chat, vector encryption, WhatsApp advanced chat privacy. Like these are all articles on the topic of chat control, encryption, secure communication, etc. So this is like very neat if you want to extract structured information from free text. And that's that. Yeah, so these are two very short demos, but happy that I got to show them both off. Any questions on that?
Yeah, I have a question. I'm looking for a way to raise my hand, but I don't know how.
I think that's fine.
You show, so the API, the task API looks like a combination of what we'll call like lower level tasks where you can kind of use a model as an input, and you can specify like a type of type of behavior like classification, and so you can sort of kind of create that we'll call that lower level. And then some of the tasks like ingestion looks like it's a wrapper for libraries that are very popular and useful
Yes.
for doing certain things. And so you have like this comment. So okay, I understand that. So then we just go to you can kind of use your documentation for C. We can go to the reference documentation. And to a certain extent, it's a library of like tools and libraries that you all have curated that you think are like very good for the particular tasks, like docling
Yes.
with ingestion. Okay, that's cool too.
Yes. So to be clear, like the Sieves does nothing that you can't do with other libraries too. The goal was not to like bring like a fundamental new feature to the scene, but to bundle like all of these very good tools that already exist and just make it easier and quicker to use them to come up like with a working prototype for these things. So it's like mostly dev ergonomics. That's how I see it. But you can do any of those things. Like if you want to structure like these information extraction thing or like classification, there are other tools you can also use, But yeah, the idea is to bring them all together and to create an interface that makes it very easy and quick to do so.
But then there also must be a not too hard way to create your own tasks with defining inputs and outputs. And,
yes. Yeah. And what you said before, that these different types of tasks, yeah, that's true. So like I distinguish them into predictive tasks. Predictive tasks are the ones you need a model for, right? This is where you need a machine learning model to say, okay, this is the text, and then I classify it. This is a predictive task. And then there is these other tasks that are, for example, the ingestion task, or like ingestion is, I think, actually the only one in this category at the moment, where you don't need a model and you just like use some sort of tool that already exists, like to extract information, to convert PDFs into text, for example.
Very cool.
Raphael, I have a question for you.
Yes.
Mike, I see you raised the hand. Hopefully.
No, go ahead. I had a question already, so it's your turn.
During the tech check, Raphael, you mentioned that you're in the middle of a major Sieves release, and I'm curious at a high level, what's changing and what should users be most excited about?
What will change? Hopefully not too much. So like the interface should have finally stabilized mostly. I mean, we're still below version 1. So we want to move towards version 1 now, which means that we can like freeze the interface, right? So that users that actually use Sieves can expect that the code continues working if there are new changes. Right now, since we're still below version 1, it can happen that if we push a new change, then like backwards compatibility breaks. But with from version 1 forward, this will not happen anymore. Mostly this will include just better documentation, more examples, eliminating some bugs, making sure that things work smoothly, that kind of stuff. So it's like mostly quality of life, unless that like some brand new feature will be added.
Very exciting. Thank you. Mike, please go ahead with your question.
Yeah, thanks for the great talk. I have a question about a use case. Let's say I want to use some system, some software, something else, and it's big. It has a lot of documentation, but I don't know where to start. Would it be a use case? Okay, I would like to structure this documentation, has a lot of different documents, and I want to kind of read out the stuff that I really need for my task. So ideally, I would just say, this is my task. Which part of the documentation is relevant for me? Can you take this out? And can I kind of create a customized documentation for my task, throwing away maybe 80% of the other documentation which is not relevant, and just focusing on the relevant parts and the examples what I was there. Would it be a useful use case?
You can certainly do that. So like you're talking just on a personal level, right? You're using some particular project and
on the personal level
or
more on general level, because I work with systems that have a very big documentation, and sometimes it takes you a long time to figure out what is relevant for you, what's not, because there's a lot of stuff there that you might never use. So, but since you're very experienced, but if you're new to something, that might be a little bit overwhelming. What part of the documentation do I need, and which is really important. And I don't know if this would be something that would make sense to you. You kind of restructure documentation by this criteria and put them in a different format that might be better for you. So instead of a very long narrative, you have a more like pass, do this, do this, do this, which is somehow inherently in the documentation, but it's really hard to get it because you have to read a lot and you get it more condensed for your use case. Something like this.
So if you have a good idea about how to transform this documentation into like a different version of the documentation, it's like more condensed and more focused for you and works better for you, then yes, I can absolutely see that how that would work with Sieves. If it's more like of a recurring thing that you're like using the same documentation, but maybe your requirements change, maybe you're looking for like different things this time around, like maybe you want to highlight a different part of the documentation, then probably makes more sense to have like a retrieval system, like a RAG or something like that. But in this case, that depends on the detail of the use case. So I can only say like maybe. I can see both ways.
Okay, thanks.
All right. Inessa, I think there are no further questions.
Let's allow another few seconds. Anyone in the audience? I know some of you joined later. Hopefully it was enough for you to catch to get excited about Sieves. Do you have any questions? Going one, going two. Right. If you think of any questions, feel free to share them on our mailing list for the OSA community. But for now, we will wrap up. Raphael, thank you so much for this tutorial. I mentioned before, I hear great feedback about Sieves in the SciPy community, and I'm excited about the future of the project. So please keep us posted now that you'll be joining the OSA community as well. We have
I will.
I will share what we're all working on, and this will be great to keep up with the development. And to our attendees, thank you all for spending time with us today. I know you have a lot of options. If you decide to adopt Sieves in production or have some cool project to share, like a hobby project, I would love to hear about it. And if you run into any issues or have ideas for future development, it is open source. Sieves is open source. I shared a link in the chat.
Yes, absolutely. Please, like if you want to try it out and you have questions or you want something like, tailored for your use case, I'm very happy to have a look at that. I'm usually very responsive to the GitHub issues. So please do get in touch if there's anything you want to know or you want some help with.
Awesome. And I'll be posting the presentation on the Open Teams YouTube channel in the coming days. So if you missed anything or just want to revisit the highlights, it'll be there. Just keep an eye on your inbox. And I truly appreciate you all being here. I hope you all have a wonderful holiday season.
Yes, you as well. And thanks for your time, everyone. Drop us a star, get in touch, and have nice holidays.